Let's look at another application of trigonometry in right triangles. So suppose we're walking down a straight stretch of beach and we notice that there's a buoy directly offshore. And after we walk 500 feet further downshore, the buoy is 78 degrees offshore. How far is the buoy from you and how far offshore is it? So to get a handle on what all of this is saying, let's draw a diagram. I always like to draw a diagram when I can, just to have some sort of picture to reason with. So let's see, here's the shoreline maybe. And maybe the water's over here. And offshore somewhere there's a buoy. So we're starting here, and then we walk 500 feet this way. So this distance is 500 feet. And then we measure this angle, and this is the angle that's 78 degrees. So of course I've exaggerated things, right? Really this angle shouldn't be as large, or it shouldn't be as small as I've drawn it, since 78 degrees is much closer to a right angle than this. But you know, we don't need the picture to exactly reflect the situation. It just has to be close enough to help guide our thinking. So what are we trying to find? Well, we need to find how far the buoy is from us, but we're over here, and so we need to find this distance. We also need to figure out how far the buoy is offshore, but that's going to be this distance here. And I guess I should mention that when I say that the buoy is directly offshore, what I mean there is that it's directly out from shore, so that this is a right angle right here. Okay, so why don't we name the things that we don't know and that we're looking for. So we're looking for the length of this hypotenuse of this right triangle, so let's call that h. And we're also looking for this red side. We could call that, I don't know, how about y? And this length on the bottom side, just to give that a name, even though we know it, we could call that x. And so we know one side of this right triangle, x, and we want to find the hypotenuse and also the opposite side, y. So we should use trig functions, right? If you know an angle and a side, you can use the trig functions to find the other sides in the right triangle. But which trig function you use depends on which side you know and which side you want to find. So since we know x, we should use a trig function that has, so x is the adjacent side, so we should use a trig function that has the adjacent side in it. And let's find h first. We want to find the hypotenuse, so we should use a trig function that has the hypotenuse in it. So we should use a trig function that has the adjacent side and the hypotenuse. So that's going to be either cosine, which is adjacent over hypotenuse, or secant, which is hypotenuse over adjacent. But, you know, sine, cosine, and tangent are the big three. If you can use one of the big three, use one of the big three. So let's use cosine. So cosine of this angle, I guess we could call this theta. Cosine of this angle is the adjacent side over the hypotenuse. Okay, so cosine of 78 degrees is the adjacent side, which we know is 500, over the hypotenuse h. And now we can solve this for h. H is 500 feet divided by cosine of 78 degrees. Okay. And then we can dump this into a calculator. 78 degrees is not one of the nice angles, so we have to use a calculator to get a decimal approximation. So make sure I'm in degree mode here, then 500 divided by cosine of 78, and I get 2,404.9. And this is going to be in feet, right? This 500 up here was in feet, and the number that comes out of trig functions doesn't have any units. So this cosine of 78 degrees, that's a pure number. So we get feet divided by just a number. That gives us feet for our resulting unit. All right, so after we've moved this 500 feet downshore, we're 2,400 feet away from the buoy. Okay, well now let's find how far offshore the buoy is. That's this red side, y. So again, we know the adjacent side, and this time we want to find the side that's opposite the angle. So we should use a trig function that has the adjacent side and the opposite side. How about tangent? Tangent theta is the opposite side over the adjacent side. So tangent of 78 degrees is the opposite side, which is y, divided by the adjacent side, which is 500. And then we can solve this for y. Y is 500 times tangent 78 degrees. And again, 78 degrees is not one of the nice angles, so we have to use a decimal approximation. So we'll take tangent of 78 degrees and then multiply that by 500. And I get 2,352 feet, approximately. You know, this is a decimal approximation here. And there we go. So you can see if you have a right triangle and you know only one side, you can always find the other sides using the trig functions if you have an angle. The only delicate part is choosing the appropriate trig function based on the side that you have and the side that you want.